Hey campers, this is Dr. White. We're going to go over some more stoichiometry problems. These stoichiometry problems are going to involve limiting reactants. Okay, so we're going to kind of work through them and hopefully you'll get the hang of it. If you'd like to follow along on your own worksheet, you can download a worksheet by clicking on the link in the description. Okay, here we go. So here we've got a problem where they're talking about 0.5 moles of aluminum reacting with 0.72 moles of iodine to form aluminum iodide. Now, first thing we have to do is we always need to get the balanced equation. Okay, so let's go ahead and try to write that out. Aluminum. Okay, well, if it's aluminum just by itself, then it's just Al. Okay, and it reacts with iodine. Remember, iodine is one of your diatomics to form aluminum iodide. Okay, so we'll write down aluminum and then iodide. Now, we always need to check our charges to make sure we're writing the correct formula for our compound. So if aluminum is +3, you can get that from the periodic table, and iodine is -1, what's the correct ratio of iodide to aluminum? Well, to offset the 3 charge, you're going to need 3 iodines. Okay. Now, once we have our correct equation, now all we have to do is balance it. So let's go ahead and do that. 1 aluminum, great. 3 iodines, 2 iodines, that's not going to work. Let's put a 2 here to even that number out. That way we can put a 3 here, and then we're going to need a 2 here at the end. So now we've got a balanced equation. Now, here's the thing. We need to solve this problem. We're going to need to use our handy-dandy BCA chart. Okay, and it's just a way of keeping track of how many reactants we have before the change that happens in the reaction, and then afterwards, how many products do we have, and if we have any leftover reactants. So let's go ahead and fill this in. Before the reaction starts, I've got 0.50 moles of aluminum. Okay, I've also got 0.72 moles of iodine, and I'm going to have 0 moles of the product because we haven't formed it yet. Okay, now the question is, okay, we want to know how many moles of the excess reactant are going to remain. So one of these, so we're going to react both of these reactants, and one of them is going to run out before the other one. Okay, so let's try to figure that out. The way that I try to figure it out is I pick one of my reactants. I pick the easier number to deal with. Okay, in this case I'm going to choose 0.50 moles, and I'm going to ask myself, if I were going to react 0.50 moles, how many moles of the other reactant would I need? Okay, so let's go ahead and do that. If I was going to react 0.50 moles of aluminum, how much of the other reactant would I need? Let's go ahead and set up a ratio for that. Okay, so if I have 0.50 moles of aluminum, how many moles of iodine am I going to need? Well, I can figure that out if I use my molar ratio, if I use these coefficients that are in my chemical reaction. So I know that for every 2 moles of aluminum, I'm going to need 3 moles of iodine. So if I work out the math on this and figure out what X is, we're going to figure out that for X, I'm going to need 0.75 moles of I2 to react with 0.50 moles of Al. Do I have 0.75 moles of I2? Well, if you look at this number right here, you can say that I don't have 0.75 moles of iodine. That means that I'm going to run out of this reagent first. This is my limiting reagent. That means that this is the important number. to try to figure out how much product I would make, and also to try to figure out how much of this is going to be left over. So let's go ahead and carry this number forward. So if I'm going to react all of my iodine, how much aluminum am I going to react? Well, if I'm going to react 0.72 moles of iodine, I want to know how many moles of aluminum that's going to be if I keep my ratio of 2 to 3 from my reactant. I'm just going to do a quick bit of math on my trusty old iPhone here. Actually, whoops, sorry, I'm using the wrong ratio. This should be 3, right, because that's iodine, and this should be 2 because that is Al. So, okay, if I go through this with my limiting reagent, I find that I'm going to react 0.48 moles of aluminum. Now, if I start off with 0.50, if I subtract the two after my reaction's finished, I'm going to have 0.02 moles left. I'm going to have 0 moles of iodine left because that's my limiting reagent. And then I'm going to use the limiting reagent number to figure out how much product I'm going to make. So I'm actually going to make 0.48 moles of aluminum iodide. How do you think I got that number? I'll let you kind of figure that out on your own. Okay, so let's go back to the question and see if we've answered it. How many moles of excess reactant will remain? 0.02 moles of aluminum. And then how many moles of aluminum iodide will be formed? That's this number right here. We're going to make 0.48 moles of aluminum iodide. Okay? Next up, number 4. Now we've got a similar type of problem. They're going to give us two quantities of reactants. They're going to want us to tell them what the it looks like in this one. It's calculate the mass of sodium sulfate produced. Okay, so let's go ahead and dive right in. First step, always get that balanced chemical equation. Okay, sodium hydroxide, okay, NaOH. Sulfuric acid, H2SO4. Arrow, water, and sodium. Okay, we need 2 sodiums per sulfate, remember, because sulfate is 2- and sodium is +1. So I believe we should be balanced. Okay, let's go ahead and set up our BCA table, right? Before, change, after. Okay, let's go ahead and put in some values here. Okay, now here's the thing. The question gives us the values in grams. Now, why do you think it gives it to us in grams? It gives it to us in grams so that, because that's the way that chemists actually operate. They operate in grams. I'm going to write the grams in here. Sodium sulfate produced from 15.5 grams of sodium hydroxide. Okay, and then 46.7 grams of H2SO4. Okay. Now, they give us the grams because that's how the chemists actually weigh stuff out. But we can't put grams into our BCA table. The BCA table only works with moles. So let's go ahead and convert those over really quick. Okay? So I know that for sodium hydroxide, 1 mole of sodium hydroxide weighs 40 grams. If I've got 15.5 grams, how many moles of sodium hydroxide do I have? Let me go to the iPhone. Okay, 15.5 divided by 40. Okay, I've got 0.39 moles of sodium hydroxide. Okay, let's do this real quick for the sulfuric acid. So if 1 mole of sulfuric acid is, how much is 1 mole of sulfuric acid? H, you got 2 H's, it's 2. Sulfur is 32. 4 oxygens is going to be 64. We're looking at 98 grams per mole. So let's put 98 in here. Grams. How many moles is 46.7 grams? X equals 46.7 divided, 46.7 divided by 98. Okay, so we're looking at 0.48 moles of sulfuric acid. Okay, now we can go in and fill in our BCA table here. Let's go ahead and do that. Let me get back to red here. So, sodium hydroxide, 0.39 moles. Sulfuric acid, 0.48 moles. Now the question is, which one of these is my limiting reactant? Well, let's go ahead and ask that question again, assuming that we're going to react 0.39 moles of sodium hydroxide. How much sulfuric acid are we going to need? Well, if the ratio is 2 to 1, right? Sodium hydroxide to sulfuric acid, I'm going to need half that much of sodium hydroxide to fully react with the sodium hydroxide. So it's going to have to be 0.19 is what I'm going to need. Okay. Do I have that? Yes, I do. I've got 0.48 moles. Let me go through and show you that, just so you know what I'm talking about. I'm going to assume that I'm going to react 0.39 moles of sodium hydroxide. The question is, how many moles of sulfuric acid would I need to react with 0.39 moles of sodium hydroxide? Well, I know that my ratio of sodium hydroxide to sulfuric acid is 2 to 1. So in this case, I would need 0.19 moles of H2SO4. Right? Do I have that? I've got 0.48. I've got more than enough sulfuric acid. That means that this is my limiting reagent. In this case, sodium hydroxide is my limiting reagent. What does that mean? That means it's going to be completely used up. So the change, 0.39 moles of this, okay, I'm going to react 0.19 moles of this. At the end of the reaction, I'm going to have 0 moles of this left. I'm going to have, looks like 0.29 moles of this left. Let's go ahead and work these out. Okay, before the reaction, I've got 0 and 0. If I react 0.39 moles of this, I'm going to make 0.39 moles of water, right? Just using the ratio in my reaction. And then I'm going to make half as much sodium sulfate, so it's going to be 0.19 moles of sodium sulfate. Okay. Okay, now the question is calculate the mass of sodium sulfate, right? So let's go ahead and turn these moles into mass. The way you do that is just by setting up your molar mass ratio. So if for sodium sulfate, 1 mole equals, let's see, let's calculate that out real quick. So 2 sodiums is 23, right? So 46 plus 32 plus 64. That's looking like 96. Add those up real quick. 96, 102, 142. It's 142 grams. Okay, if we've got 0.19 moles, how many grams is that going to be? Go to the trusty calculator. .19 times 142. We are looking at 27 grams of Na2SO4. That is our answer. Okay, so what do we do? First step, make our balanced chemical equation. Second step, do the BCA, but remember to do the BCA, you need the moles, okay? Third step, ask the question, okay? If, how much do I need? Okay? And then step 4 is always look back to your question to make sure you know what to answer. Okay? This video is running a little long, so I'm going to cut it off here, but feel free to download the worksheet off the link in the description. Thanks.